Okay, so we use theorem 1 because angle B is at the center, so it's at the circumference, and angle O1 is at the center. So we use theorem 2 as I did there. So this becomes angle B is equal to half times 130 degrees, and you get 65 degrees. So give yourself another mark for the size of angle B. So this is 4.3.1a. Okay, it's not difficult. Okay, it's not difficult at all. So this is how you're supposed to approach the question. Right? Please don't do your own thing. Okay, the way that I do things when I'm doing examples, that's how you're supposed to do to answer the questions. Okay, don't start doing your own thing. Okay, then 4.3.1b, 4.3.1b. We now need to determine the size of angle A. Now, angle A is this angle here. Okay? Now, both angles, angle A and angle B, are at the circumference. So, all you have to do is identify if they are subtended by the same chord. Okay? The answer is a yes, they are subtended by the same chord CE. Okay? Also, we have got a butterfly here that is AEBC. That's like a butterfly, like how she said the other day. So, angle A is equal to angle B. The reason is angles in the same segment, theorem 4. Angles in the same segment, that's theorem 4. So, angle A is going to be equal to 65 degrees as well. So, give yourself a mark for the reason, which is correct, and the answer, which is also correct. Yes.
So I saw that. What I saw was I saw that I said that A is equal to
D.
A is equal to O1 is equal to 2A because of angles at the center.
Because O1
is equal to 2A.
or they both subtended. Okay. Yes. If you saw it as an angle at the circumference, it means it's half of the angle at the center. It's also correct. Okay. So it means right here, you write angle A is equal to half of O1. Your reason, angle at the center is 2 times angle at the circumference. Therefore, angle A is equal to 65 degrees. That's also correct. Yes.
Is AECD a cyclic chord?
AECD. Yes, it's a cyclic chord. So you could take another route, find the size of angle D, subtract that angle from 180, you will get this. That could be a third way, but that's a long route. Okay. Either use theorem 4 as I did, or you can use theorem 2 as he did. But you could also use theorem 5, the cyclic chord. But that's a longer route, but it's fine if that's what you first see when you saw the diagram. Okay? So you answer the question based on what comes into your mind the moment you see the diagram. Okay. Then, so we have got B there. We now need to find the size of angle D. Now, to find the size of angle D, it's going to be easy because I already found the size of angle A. Sorry, I found the size of angle A. You can also use angle B. Okay, it's your choice there because we have got 2 cyclic chords here. We have got ACDE, it's a cyclic chord. We also have BEDC or BCDE, it's also a cyclic chord. So you could use angle B or angle A. Either of the two will give you the answer, but you have to use the theorem number 5. So in my case, I'm going to write this angle A plus angle D is equal to 180 degrees. Your reason is opposite angles of cyclic chord. Remember the acceptable reasons that I gave you. That's your benchmark. Those are the reasons that you're supposed to provide. Yes?
So if you say B plus D, will that also be correct?
Yes. It will also be correct because, as I said, angle B, or rather vertex B, C, D, and E, they form a cyclic chord. So you could also use that as well. Right? So our angle D is going to be equal to 180 minus 65 degrees, and that will give you 115 degrees. Okay, so that will be your answer. All right, so that's what you're supposed to have done. Okay, some of you, when I was moving around, I saw your answers were correct. Right. Then let's move on to 4.3.2. Now 4.3.2, it's a high order question, level 3 or 4. It requires a bit of some thinking, okay, for you to be able to do it. So I want you to be aware that this is how I'm going to approach the question. First, because we have got those two lines that are parallel, means we have to use them somehow. Okay? If you are given lines that are parallel in a diagram, it means you have to use them somehow. There is no way that they can be provided for no reason. So I'm going to use the fact that angle B plus angle C will give me 180 degrees because they are co-interior. Furthermore, if you look at triangle AOE, angle A is going to be equal to angle E, the sum of E1 and E2. Why? Because AO is equal to OE because they are radii of the circle. Therefore, angle E1 plus E2 is going to be equal to 65 degrees. Okay? Then I'll also use my knowledge of the cyclic part. The cyclic part that I'm going to use is going to be cyclic part AEDC. So I'm going to use three concepts: co-interior angles, my knowledge of the radii together with an isosceles triangle, and the cyclic part. All right? It's not an easy question to do. As I said, it's a level 3 or level 4 question. So let me move on to the next page. So first, I'm going to say AO is equal to OE. Okay, so this is 4.3.2. I'll say AO is equal to OE. My reason is that those two are radii. Once I say that, it means that angle A is going to be equal to angle E1 plus E2. And my reason here will be angles opposite equal side. Okay? Therefore, angle E1 plus E2, that will give me 65 degrees. Because already we know that angle A is equal to 65 degrees. Okay? Furthermore, if I write angle B plus angle C, these two will give me 180 degrees. My reason there, it will be called interior angles. Okay? Then I need to state the lines that are parallel. In my two lines that are parallel there, it's going to be BE is parallel to CD. So BE is parallel to CD. Okay? Now be aware that this C here is equal to C1 plus C2. So I can split it up and write that C1 plus C2 is equal to 180 minus 65 degrees. And that will give me C1 plus C2 is equal to 115 degrees. Okay? Now allow me to give names to those equations. I'm going to give this equation here a name. I'll call it equation 1, and that one I'll call it equation 2. Okay? Now, if I add equation 1 and equation 2, that is if I add the left hand side and the right hand side, right? So I'll write here, by adding equation 1 and equation 2, if I add, right, the left hand side and the right hand side, I'll get C1 plus C2 plus E1 plus E2 is going to give me 180 degrees. Because 65 plus 115 will give me 180. Don't forget, the objective is to prove that angle E1 is equal to angle E3. So I now have this equation, I can call it equation 3. Now I need another equation. Okay? In that equation, I'm going to use cycle quad A, I'll call it ACDE. Okay? I've got issues with the brightness, so this should be okay. Then wash your face with it. Right, I'm just going to repeat this. I'm going to use this cycle quad A, C, D, E. Okay, if you look at my equation 3, it doesn't have E3. I hope you can see that. There is no E3. So I need an equation with E3. Okay, it will also have C1, C2, and so on. Right? So let me move on to the next aspect, or the next equation. I think I can try to squeeze it here. Okay, let me move on to the next page anyway. So on the next page, I'm going to say angle C2 plus angle E, okay, plus angle E will give me 180 degrees, and that's opposite angles of cyclic quad. Okay, but be aware that angle E is made up of 3 angles. So I can write that as C2 plus E1 plus E2 plus E3 is equal to 180 degrees. So that equation, I can call it equation 4. Okay? Now furthermore, but angle, if you look at this diagram, angle C1 is equal to angle E1. They are angles in the same segment. Okay? So what I'm going to do is that I'm going to use that as well. But angle C1 is equal to angle E1. These are angles in the same segment. Okay, so by adding equation 3 and 4, or rather by equating equation 3 and 4, by equating equation 3 and equation 4, right, both equations have got 180 degrees on the right hand side. So I can equate the left hand side. So I can write this C1 plus C2 equals that is going to be equal to the other side. So C1 plus C2 plus E1 plus E2 is equal to the left hand side of equation 4. So that's C2 plus E1 plus E2 plus E3. Okay? I equated the left hand side. Yes.
So for angles in the same segments, it's a butterfly, right?
Yeah.
Does it have to touch 4 times?
Yes. The 4 vertices must be on the circumference.
What if it's just a butterfly and it's only touching twice?
No.
Then you can't use it.
Then it's not the angles in the same segment theorem.
Then it's an angle from
The angles must be on the circumference.
Then it's theorem 2 then, if it's not touching.
Okay, it will depend now on the shape of, in fact, when you are using the theorem 4, the 4 angles must, the vertices must be on the circumference. The angles must be on the circumference. Right? For theorem 2, one angle must be at the center, the other one must be at the circumference, and they must be subtended by the same chord. Alright, now once you get here, I'm sure you can appreciate that C2 and C2 will cancel. E1 and E1 cancel. E2 and E2 cancel. Okay? C1. Then you have C1 equal to E3. But we wrote here C1 is equal to E1. Therefore here, where there is C1, I can replace that by E1. So E1 equal to E3. Okay.
What's the value?